Hi, in this video we will learn about properties of the vector operations, the vector addition, vector subtraction, and scalar multiplications. The main reason that all these property will happen is the keyword that we learned while doing the vector operations. So recall that all the basic vector operations, addition, subtraction, and scalar multiplication operations are done. The word was component wise. And what does it have for us when we're trying to study the properties is that, well, for example, when you have u plus v, this is u1, u2, plus v1 and v2, then you know that it is component wise, meaning that u1 plus v1 will give us the first component, u2 plus v2 will give us the second component. Okay, here is where the component wise properties of number come in. Here you can forget about the whole vector and look at these as numbers. u1 plus v1 is a number, u2 plus v2 is a number. And you know that while you're adding two numbers, the order doesn't matter. 2 plus 3 is same as 3 plus 2. So here it means that I can switch this order u2, and then while I can separate this as vector addition of v1 v2 added to u1 u2, in other words vector v plus vector u. Well, see what happens that when we turn do the operation and turn the things to the components, to turn the operation to the components, then in the components you have the properties of the numbers. You can switch the order, you do it and turn back to the vectors. You see that what we found is that in vector addition also the order of vectors doesn't matter. This property, which is the first property, is called addition is commutative. You can switch the order of vector addition. Other properties that I'm going to tell you here can be done only by taking into account that these operations are done component-wise. Okay, so that's the first one. The second property is a very nice one. You won't notice if you don't think very carefully. So if I know how to add two vectors, but how about three vectors? Well, if someone gives you this, you have to break it into addition of two vectors and then turn add the result with the third one. So in other words, you can either do two first one, add two first one, and then you get a vector added to the third one, or you can add the second and third one, get a vector, and then the result you add it to the first one. This property says that addition, in the addition case, it doesn't matter which one you do, you will get the same result. This is called associativity. So vector addition is associative. What else? Okay, I can also start studying the scalar multiplication. For example, if you have two scalars, you first multiply them, you get a number, and then multiply to another a vector. This is scalar multiplication. This will give you the same thing as if you multiply d to u, get a vector, and then multiply c to that vector. These two will give you the same result. The fourth and fifth one are a nice one also. It says that the vector addition and multiplication take care of each other when it comes to distributing the addition over the multiplication. Let me show you what do I mean. So if you have a scalar number, then you want to multiply it to vector addition. This you can first, well, basically distribute. You can scalar multiply c to u, c to v, then you get two vectors, you add them. And the same is when you have two scalars added and then multiplied to a vector. That would give you the same thing as cu then plus du. These two properties are called distributive properties. These are the main properties that I want you to learn, but there are a few more things. For example, you add vector 0 to any vector. Vector 0 is a vector that has all components equal to 0. So you're adding basically components of u to 0 components, so it will give you the u back. Also, if you add u to its negative, you get, well, they will cancel each other. You get 0, but not 0 number. It will be a 0 vector. It means that it will have some components. It will be first 0, second 0, third 0, and so on. Also, when you have scalar multiplication, you can say 1 times u. Well, 1 times u, you multiply 1 to every component, it will give you the same components back. You get your u back. Or when you multiply -1 to u, -1 multiplied to each component, remember we call that operation the negative of vector, which is -u. And if you multiply 0, the number 0, this number 0, so you have to see that here I'm using number 0, this is vector 0. So 0 times scalar multiplied to u will give you a 0, so because you multiply 0 to every single component of the vector u, so all the component will turn to 0, and that is not just 0 number but 0 vector. And these are the properties. There is nothing special, nothing new here, but you have to know that in these three operations, you basically have the properties of the numbers. Later on, we will learn more operations, more works, and then over there you will see that some of these properties may not hold. One of the things that to use the properties, I can say is that, well, okay, I use properties of numbers to solve equations. I can do the same thing for vectors. So find a vector u such that 2 times u minus 1 to -3 equals to 2 times 0, -1, 1. Very quick example, let me write here. Remember, if you have a number 2x plus 1 equals to 2, to solve this, what you do, you take this one to the other side. In other words, you add both sides by the negative of this part. So it will be 2x plus 1 added to -1 equals to 2 added to -1. This and that will cancel, so it gets 2x plus 0 equals to 2 minus 1, which is 1. Then 2x plus 0 is 0. 2x plus 0 is 2x. You add any number to 0, you get that number back. And then to get rid of this 2, you multiply both sides by half. So you do half of 2x equals to half of 1. And half times 2 times x is equal to half. These two cancels, x is equal to half. So here I'm using some properties. Now I have completely equivalent or same properties for vectors, and I can use and solve this equation, meaning that I can first transfer that vector to the other side. In other words, add both sides of this equation 1 to -3. So we'll get 2u minus 1 to -3 plus 1 to -3 is equal to 2, 0, -1, 1, added 1 to -3. And you see that a vector and its negative are added. If you add a vector to its negative, see this property, you get 0 vector. So this will be 2 times u plus 0 vector is equal. Let me do the right hand side. This is 2 times 0 is 0. 2 times -1 is -2 and 2. And add to 1 to -3. Well, another thing is that you add a vector to 0. This is this property here. Add a vector to 0 vector, you get the same vector back. And the right hand side will go 0 plus 1 is 1. -2 plus 2 is 0. 2 plus -3 is -1. Okay, I know that 2 times u is equal to 1, 0, -1. To get rid of that 2, I multiply both sides by half. So I will have half of 2u is equal to half of 1, 0, -1. But you see, if you have two scalar, look at this property, two scalar, first, 1 multiplied, let me zoom out a little bit, 1 multiplied to u, then the whole thing multiplied to another scalar. We can put these two together and multiply scalars together. So I can multiply half to 2, then times u equals to half times 1 is half, 0, -half. Why is this thing important? Because half times 2 is 1, so you have 1 times u equals to half, 0, and -half. Okay, 1 times u, remember this property. 1 times u gives you u back, and that is how we find the solution, or the variable which satisfies, the vector which satisfies this equation. Again, there are more properties. We'll get back to the properties when we introduce more operations of vectors. But for now, what is important, at least, I want you to understand the commutativity and associativity and distributivity of the scalar multiplication.